Welcome to Math Shorts, tantalizing mathematical tidbits that will amaze, entertain, and delight. Math Shorts is brought to you by the Ottawa Zone for Mathematics Education. The Ottawa Zone for Mathematics Education is a chapter of the Ontario Association for Mathematics Education. Information about both organizations can be found in the information for this video.
In this episode of Math Shorts, we're going to be looking at the Sieve of Eratosthenes. Now, the first thing we need to know is what the heck is a sieve? And a sieve is an item that is used to separate one part from another part. You're probably used to have seeing one in your home. They're used very often in the kitchen. Something like this is used to sieve away and separate water from cooked items. So if something is being boiled in the kitchen, usually when you're done, you'll pour it through the sieve. The sieve will let the water go through, and it'll catch the food that you want to eat. So it's the same sort of idea that we want to use. But for the Sieve of Eratosthenes, what we're doing is we're sieving through numbers. And we're going to separate the prime numbers from all the numbers that aren't prime. And here's how we're going to do it. So the first thing we're going to do is we're going to list the numbers from 1 all the way up to some number, and that's as far as we want to go. We're going to cross out 1, and the reason we cross out 1 is 1 isn't prime. 1 isn't composite either. It's one of those. It's a very special number. But we're going to cross it out. Then we're going to go to our list and we're going to find the first number that isn't crossed out, and we're going to circle it. Once we've circled a number, we're going to cross out every multiple of that circled number, because if it's a multiple of something, it's going to be composite. And we're going to go back to step number 3 now and find the first number on our list that isn't crossed out and circle it. Go through and cross out multiples and keep going through and doing that until all the numbers have either been crossed out or circled. And when we're done, the circled numbers are all going to be primes. So let's take a second and look at this in action. So let's look at the numbers from 1 to 100. Okay, if we go back to our list of steps that we have to do, the first thing we have to do is cross out number 1. Now we look at our list, and what's the first number that isn't crossed out? It's 2, so we circle it. And now, once we've circled a number, we go through and cross out all its multiples. So 2 times 2 gives us 4. We cross that out. 2 times 3 is 6. Cross that out. 2 times 4 is 8. Cross that out. 2 times 5 is 10. Cross that out. And continue this process, crossing out all the multiples of 2 all the way up to 100. Once we've crossed them out, we go back to our list. We go through and we find the first number that isn't crossed out, which is 3. And we circle it. And now we go and cross out the multiples of 3. But if you look, 3 times 1 is 3, 3 times 2 is 6. 6 has already been crossed out. 3 times 3 is 9. Oh, there it is. It would be crossed out. 3 times 4 is 12. It's already been crossed out. 3 times 5 is 15. 3 times 6 is 18. It's been crossed out. So some have already been crossed out by the 2's, but we go through and cross out all the multiples of 3, and then we go back to the start of our list. Now we have 5. Again, if we look at the multiples of 5, we got 10 has been crossed out, 15 has been crossed out, 20 has been crossed out, 25 has not. 30 has, 35 has not. 40 has, 45 has not. 50, 55 has not. Now, if we start looking at these, 25 is 5 times 5. Well, 5 is left on the list. 35 is 5 times 7, and 7 is still on our list. 55 is 5 times 11, and it's still on our list. 5 times 13 is 65. 5 times 17 is 85, and 5 times 19 is 95. So if we look at all the numbers that we've already crossed, their multiples of 5 have already been crossed as well. So we're done with 5. Let's go on to the next number, which is 7. Oh, we got rid of the multiples of 5. Now we go on, the next number is 7. Again, if we go through and start looking at the multiples of 7, the first one that shows up is 49, which is 7 times 7. And the next one is going to be 7 times 11, which is 77. And 7 times 13, which is 91. And no others. So we cross those out. And then when we go to the next number, which is 11, and we start looking at its multiples, 22, 33, 44, 55, 66, 77, 88, and 99 are all crossed out, which means that we're not crossing anything out. And if I go to my next number, 13 times 13 is too big, and it's going to be off of our list as well, so it's not going to cross anything out. Nothing else is actually going to cross anything out. And so if I keep doing the process, all the other numbers are going to be circled and are going to be prime. So let's see a few observations. The first of all is after we've gone through and eliminated all the multiples of 2, the next time that we go through and start eliminating, some of the multiples have already been eliminated by earlier primes. The numbers that are eliminated by a prime p turn out to be that number times itself and all of the other numbers that are on the list that haven't been eliminated so far. So as a result, the first number that we eliminate when we get a new prime is its square, which means that if p squared, or our prime that we're dealing with, is greater than the biggest number in our list, there's nothing else that's going to be eliminated by this or any other prime, which means that everything is going to be a prime. So let's just take one last look of this process, but with a bigger list. So now we're going to go up to 800, but we're going to go through pretty quick just to see how quickly this thing does it. So first of all, if we look, we get rid of 1. So our first prime is 2. We eliminate everything from it. And actually, if we look at 2 squared is 4, 4 is going to be the first one that's going to be eliminated. If I look now, my next prime is going to be 3. 3 squared is 9 is going to be the first number that's going to be eliminated. 5 is going to be prime. 5 squared is 25. So 25 is going to be the first number that's eliminated. 7 now is going to be prime. 7 squared is 49, and 49 is going to be the first number eliminated. 11 is the next prime. 11 squared is 121, and so 121 is going to be the next number eliminated. 13 is prime. 13 squared is 169, so 169 is going to be the next number eliminated. 17 is our next prime, and 17 squared is 289, so 289 is going to be the next number eliminated. 19 is our next prime. 19 squared is 361, so 361 is going to be our next number eliminated. 23 squared is 529, so 529 is going to be our next number eliminated. And 29 is our next prime, but 29 squared is 841. and 841 is off of our list, which means that all of the other numbers are prime. So if you look, this process, we didn't even have to finish up the first row, and we've basically found the primes in our whole table. And this is a process that allows us to find the primes. If you program this on a computer, it can go through and spit things out pretty quick. Unfortunately, if I want to go to really, really, really large numbers, I still have a lot of checking to do, because I've got to basically go through and cross out or circle every number in the list, and some get crossed out more than one time, so that if I'm going up to 800, my computer actually has to deal with every number at least once, and in some cases more than once. So I'm going to have to deal with 800 numbers. If I wanted to go up to 1,000,000, I'd have to deal with 1,000,000 numbers, which for a computer isn't too bad. But even for a computer, if we get larger and larger and larger, it's going to take too long to do. So mathematicians actually have other ways to determine if things are prime or not, and they use those for further prime testing. And maybe we'll look at some of those in a future episode. I hope you've enjoyed this episode of Math Shorts. Tune in next month for another episode. Until next time, keep playing with mathematics.